Introduction and history. The optics is derived from a Greek term "pto," that means appearance or look. It began with the development of lenses by the ancient Egyptians and Mesopotamians. Hassan ibn al-Haytham, referred to as the father of modern optics, was a polymath, an Arab mathematician, astronomer, and physicist of the Islamic Golden Age. He made significant contributions to the principles of optics and visual perception. His most famous work on optics is in his 7-volume Kitab al-Manazir, that is Book of Optics, written during 1011 to 1021. Physical or wave optics. In physical optics or wave optics, light is considered to propagate as wave. This model predicts phenomena such as interference and diffraction, which are not explained by geometric optics. The speed of light waves in air is approximately 3 into 10 raised to the power 8 meters per second. The wavelength of visible light waves varies between 400 and 700 nanometer, but the term light is also often applied to infrared, that is, whose wavelength is between 0.7 to 300 micrometer, and ultraviolet radiation, whose wavelength is between 10 to 400 nanometers. Now we have covered this part of physical optics or wave optics under the section of waves. I have here given a few examples from my previous lectures under this topic. Geometric optics. Geometric optics describes light propagation in terms of rays. It does not account for certain optical effects such as diffraction and interference. Now, geometric optics or ray optics describe the propagation of light in terms of rays, which travel in straight lines and whose paths are governed by the laws of reflection and refraction at interfaces between different media. These laws were discovered empirically as far back as 984 AD and have been used in the design of optical components and instruments from then until the present day. In geometric optics, we assume that light rays propagate in straight lines as they travel in a homogeneous medium. They may be absorbed or reflected. They bend, may split in two in particular cases at the interface between two dissimilar media, and they follow curved paths in a medium in which the refractive index changes.